feels like standing in front of the classroom in the early days. I would like to start. I have like probably 45 minutes with a lot of content because this can also be an hour talk, so I will do my best to keep it within bounds. So stick with me because in the next 45 minutes, I'm going to talk to you about using GenAI on and mostly also inside your code base or code and what could possibly go wrong, right? There's a lot of good stuff or bad stuff, depending on how you look at it, that I'm going to talk about. First, briefly introduction, big picture, big face. My name is Niels Tanis and I work as a security researcher for Veracode. I have a background in .NET development, security consultancy, pen testing. Done a lot of it, quite fun. Building software is still the thing that I enjoy the most. And in my day job, I mostly focus on static analysis of .NET. If you want to talk about Veracode, come see me afterwards. I'm going to mention Veracode once, because we have an industry report that I want to touch on some statistics. But that's about it. I'm also doing a lot of Rust, and I'm Microsoft MVP. But let's get this started. So generative AI. I think everybody probably gave a shot at generating images. And this is Bing Image Creator, I believe. And I asked it to create a LLM machine that generates source code. And this is what you get. And you can definitely see that something is a bit off, right? You definitely can recognize that something is being generated. And it's not completely how it's supposed to be, especially the one on the right side. It's steampunky kind of thing with a lot of big stuff compared to what's around it. The middle two ones, I did it already a couple of times. Hopefully it stays like this. Those two to the left maybe are a bit more like normal. If you looked at something called Sora that can generate videos for you, right? There's a couple of them that say, I think they did like some bad stuff happening in Amsterdam, but you could definitely see on the angle and the way that people were walking and direction that it was fake. There was something not right? And that's because it's visual, we can see it. And we can use generative AI in a lot of spaces and also on our software, right? To help us out coding or to integrate it inside our applications and do some real cool stuff with natural language because you can talk to your application and ask it to do things and also to misbehave, right? That's the other part of it. So looking at AI in general, I think we can define 3 layers. If you look up Microsoft, has got a really nice course on AI security fundamentals. Search for it. It's on the Learn section of Microsoft. You will have 3 layers. You have the UI, the AI usage layer. So I'm consuming stuff like an LLM directly, maybe ChatGPT. You open it up, you talk directly to it or some model. You have the application layer where you take an LLM system into your own application and talk to it, right? Throughout maybe semantic kernel or something else, or maybe direct client libraries, depending on what you want. And then we have the platform layer itself, so we need to host models somewhere in order to scale. Models itself also need to be built, need to be trained. There's a lot of stuff involved. But based on these 3 layers, you can define a whole threat landscape. And there are several into this, and we're going to touch all of them in this presentation. I'm briefly going to touch LLMs, not going to spend too much time on it, but then we're going to look into like, hey, if you use it inside your code, like what would it be? You could probably, everybody has used Copilot or Cursor or maybe something like Windsurf. There's pretty cool tooling happening right now. It gets me excited. There's a lot of productivity we can get out of it. But there's also a lot of stuff we need to still keep an eye on, right? That's what I want to emphasize during this talk. Then we're going to also look into, as I said, integrating it and then how LLMs are built. There's a supply chain. People who've been in my sessions in the past, I also talk about software supply chain, right? Starting with something, ending with something in production, and the whole steps in between is something you need to keep an eye on. What's next? And QA at the end. So large language models, right, are just transformers, regressive transformers that will do some stuff based on what it was learned to, right? So there's a set of data that it had learned upon, and then some math and some functions will make sure it will iterate through and it will produce an answer for you, right? And based on what it has seen, the different models, right? There's a data corpus that every model uses. There's some problems with that, but once you ingest it, then it will provide you answers, right? And it's pretty outstanding. And 9 out of 10 times, if you do stuff with an LLM and talk to it directly, and you get a wrong answer, you're probably asking the wrong thing or giving it like maybe a too shallow context. You need to make sure that it knows more. But attention is all you need. That's like one of the first research papers that was produced, and the right diagram also sits in that paper. That will tell you how it works. There's also a real good series on videos by 3 blue, 1 brown. If you look through it, that's like a person that will explain to you how these things are being built up with vectors and with all stuff happening internally. I like it a lot, right? So how would this be completed? Of course, you see like, hey, Paris is a city and then the next one. And also seeing it in more of a, let's say, context of how a prompt would use, right? So, hey, I'm there, I'm visiting Santiago, please give me some good advice on what to visit, right? These are all the basic stuff that we see with LLMs, and that can help us out. The biggest problem with LLMs is that they are non-deterministic, which means the answer won't be the same, right? Each time it might be different. Of course, there's stuff you can tweak. There's things that can be put inside bounds. If you would ask GPT, I think GPT 3.5, ask how many R's are in strawberry, it's wrong. It will, because it's like looking at a context window and just one R, and it doesn't count, right? And what you then mostly see happening, I think with GPT in particular, it will generate a Python program that will do the calculation for you, right? That Python program is deterministic because you put something in it and it will give you the output. And in conjunction with that, right, LLM agents, plugins, we're going to touch it in a bit, it can become more deterministic. But there's also, it's the fundamental way how it works. But if you put an LLM inside your software, it could probably happen. Like if you don't put the nice bounds around it, or not keep attention to what it's allowed to do or not, then we end up with a lot of problems and funky stuff. Everybody knows GitHub Copilot probably, or Cursor, right? Those are the two ones. I saw Windsurf yesterday, a demo. It's like more agent-based. Oh, there's so much cool stuff happening. It's so quick how it evolves and how people are connecting things together. But it will give us productivity, right? And I think that's the key thing. Productivity is good. One quote from Glenn. Glenn, if you have been to an NDC conference, you probably have seen Glenn present on this variant of topics. He had a nice thing on Blue Sky in December where he says, like, hey, AI programming is like pairing with an old dev, which is drunk. It probably will produce pretty good advice, right? But you need to check everything. And sometimes it's advice a bit like outdated because the model hasn't seen that data, right? That's usually what happens. And it's nonsense. It's like, oh yeah, sorry about that, right? There's always that you need to keep an eye on and make sure that you don't fully trust it. Bruce Schneier once said, like, hey, LLMs are like the minions, right? They will probably work for you if you give them good instructions, but they can also make a big mess out of it, right? That's the thing. And yeah, we need to keep an eye on. So taking the whole LLM route, as I talked about, what's then the relation with software security? So each year within Verico, we produce the State of Software Security. This is the edition of last year. 3 weeks ago, we published 2025 edition. But this one has some statistics that I would love to share with you in order to get a grasp of like how good is the industry doing when we are producing code, right? So, and we want to address the threat of security debt. And security debt in our vision is a security problem that has been around for more than a year. So let's say we analyze an application for our customers, then it starts at some point, and then 1 year later, that thing is still around. And that's debt. That's something you would drag with you. Like technical debt, similar, but this is security debt. So one of the graphs we have in this report, and I hope everybody can see it a bit, is the amount of flaws that were newly introduced, right? And in combination with the application age. And you see at the beginning when an application gets developed and you start to work on stuff and needs to be deployed, then flaws will be fixed, right? There's a steep curve going down. That's the honeymoon phase, as they put it down there. But then at the end, what we see in general is that the trend will always be upwards, right? Because you probably do more features, you increase more stuff, you add more functionality to your application, and the likelihood of the flaw count going up is pretty high, right? And you will keep dragging that with you. And what we have also seen is that in 2024, almost 70% of the apps that we have seen have security debt. So they have problems that have been around for longer than a year. And 45% of the organization, so a bit less than a half, have critical security debt. Those are the big problems. And of course, there might be risk assessments done, and there's a bigger problem, but it's quite significant. And in this year's report, the first one is 74, and the last one is 49, so it has increased as well. There are also some good metrics. I'm not going to talk to you more about it, but that's just a trend. And one thing that's the most worrisome is that if we look in general, is that 2 out of 10 applications have enough capacity to reduce the security problems they have over time. So the other 8 will just accumulate more. We'll just get more problems tied to their system. And that's quite significant, right? And then we're going to get into this in a bit because, like, we produce more functionality, we produce more code. That's probably what's going to happen, right, with GenAI. And it's a risk. So 2 out of 10 apps are able to keep up with it. And that's good, but the other 8, I think the newest figures were a bit more as well. I need to look into it. But hey, why is software security hard? I think that's always a question Security knowledge gaps in general. People need to be trained, need to be aware of something being a problem if you use it in a certain way. Applications with cloud native and all stuff I've seen earlier is becoming more complex. Applications are literally everywhere. Started out with the monolith, right? One big chunk that you just deploy on one machine, compared to I want to deploy on cloud and I want to auto-scale all of it. It makes it hard. There's also incomplete view of risk, right? We have software with problems, but we have all the environments as well, all the risks tied to Azure being wrongly configured, or AWS, or Google Cloud for that matter. And stuff is found over time, right? That's still, I enjoyed seeing that. If new stuff gets published and people find things. But then let's add an LLM that generates additional code for us. What will happen if we do that? The right side is a meme that a colleague of mine created. It's like, hey, I trained my model on all world's code, but then the question, of course, would be, you took out all the things that's bad, right? All the exploitable stuff, it should go, which of course is not the case. So looking at it, there's a lot of research done that will explain what happened, like with this kind of thing. And the first paper that was 2021 was published, was called Asleep at the Keyboard. I think this was also published at Black Hat, a big security conference. And out of almost 1,700 apps, 41% of the apps contained vulnerabilities of stuff that was being generated. And the conclusion was, like, hey, you still need to pay attention, you need to be awake if you're programming stuff, right? I heard somebody talking about vibe coding this week. I'm just trusting what the LLM produces, or that's a bad thing, because this is, of course, this might be outdated. We're going to get to more current research, but this is definitely something to be aware of, right? You need to be aware of the productivity. You need to be aware what you produce. And it's at the end, it's still code. It ends up in your code base. Another thing that was done in, I think, 2024 was this one published in December, republished. They had 435 apps generated, and 36% contain a security weakness. If people want to have the slides, I will share the slides at the end. There's a PDF. You will have it all, including the notes and the links to all of these papers. And that was done on a variant of programming languages. The fun fact is that they also were able to fix 55% of the flaws, because if you give the LLM enough context saying, this is a problem, you need to rewrite it, it can do a good job, right? So that's cool. So that's already saying, like, okay, by default, it generates stuff that's wrong, and models do evolve, become better for sure. And that's what we see in the second bit. And then, as I said, the vibe coding part of it, developers using LLM are more likely to produce insecure code. That's what this paper was about. This one was published as well in 2024, I believe, right? No, 2023. But there was a lot of confidence, like, hey, the code looks good. I'm just going to take it, right? And that's the thing, like, hey, is it a good thing? I don't know. The other aspect we need to be aware of is, like, hey, how good are all the models with generating code? And this is a nice framework that will have a base set of prompts to create like a benchmark. And they generate code for each of the different models. And then they checked it based on security problems and security vulnerabilities. And then they figured out, like, hey, StarCoder is definitely the best at doing code, then GPT-4, and then the other ones. But also, they also have a nice metric in it, because it might be better to produce non-vulnerable code, but it also needs to function, the other aspect of it. And then GPT-4 will still, at this point in time, was the best one to choose. But it's good. These benchmarks need to be around for us to measure how good LLMs are, and maybe pick the right one that we want to choose as a base, right? There's always stuff you can do on top of it as well. But that's the thing. And then getting to code, as I said, all of it ends up in code that we use. And this is a paper that was published in February. I was really happy to see this one, because this like extends the story that I'm talking about right now. So this is a company called GitClear, and they did a metrics on 211 million lines of code. And looked into it, like how people behaved in order to, like, how they work with that source. What they did see is that there was a really increase in code duplication. Big chunks of code are just being copied all over the place. An AI tool will probably generate the same bits for you, and you would just put it in, right? So that was one of the conclusions. The other one is that there is also an increase in code churn, meaning that big blocks of code got replaced after change sets, which also mean, like, hey, let me generate this code for you and then replace it. AI again, right? Copilot. Maybe it's a bit more picky right now. Oh, let's please stay here. Okay, I'm not touching anything. I was already thinking, like, hey, maybe if I wobble, it's not the plug, it's not me. And we also see a decline in refactoring. Normally you would say, hey, I'm going to rewrite this code. I have one single implementation to do this. Let's take that route. So the productivity boost is definitely a benefit, right? If you see, as I said, windsurf, look into that one. If you see the productivity with agents and it can work with you and help you out, taking the right decisions, it will learn more. It's cool, but it will have its effect on long-term code quality, and that's a big problem. And if we then conclude and say, okay, code velocity goes up, we produce more code, but it will fuel the productivity, that's good. But the code reuse part has gone down, right? So we have more duplicates. Last year, we also had a section in State of Software Security saying like, hey, and an LLM is an average developer on how secure it will code. That's still something we can stick with. So the vulnerability density is similar, but because we produce more code, we will have more problems. And at the end, what can we do, right? It's just code. You could say, yeah. As I said before, the prompts and the way you instruct the LLM or maybe your tooling can help out producing better stuff. That's fine. And there's also some good stuff happening with models that improve over time and become better at reasoning, right? Those kind of things. But we still need, and then the security advocate pops up in my head, like we still need to do security design, we need to make sure what our risks are, we need to do all the testing, we need to do the code analysis. This is a quite long one. Oh, it's getting longer each time, then I probably need to speed up, I don't know. So static analysis, dynamic analysis, and of course education. It's all part of the whole thing. Security is a development life cycle. It needs to be integrated into what you do, and it's not an afterthought. And the same counts with, it's just code. We are trying to look into like, hey, if we have our own statistics on analysis, so like at the end it's just code. We cannot identify what the differences are if we look at it from a static analysis perspective, right? That makes it hard to understand. There is a thing that can help us out. Let's just drop another LLM on top of it to help us out. As I said, better prompts, but we can also have GenAI helping out fixing stuff, right? And of course we have a product, and I put every alternative down to make sure that I'm not like biased, but you can do GitHub, right? Mob has got some tooling. SamGraph has got a whole assistant that you can walk through. There is some real good tooling happening right now that will hopefully give us also the velocity to fix stuff more quicker. I think that's the key take on it, right? So good stuff. Hopefully, and I'm going to touch a bit more on this because there's a lot more happening in this space as well. But in order for us to keep up with the velocity and make sure we can decrease that security debt and have that trend that goes down, we need to have better tooling and we need to work on that. Keep in mind that if you have a single code snippet that can be replaced by something that's secure, that's a good thing. But can you imagine an LLM replacing a crypto implementation that encrypts the data in your software and have it replaced by an LLM? It's not going to happen unless it's probably a well-trained, like really narrow model. I don't think it's going to happen because it's too complex. It's the same as rewriting architecture of your software, right? You need to rethink things in order to get that. But there's definitely some good stuff in this case. And as I said, I'm happy about that. Okay, so we've talked a bit about GenAI. I'm going to talk more about code and some other stuff at the end. Now I want to move a bit more into, hey, we can integrate LLMs into our applications as well. Semantic kernel, a nice SDK. There are different others that you can use to directly integrate, right? Which is pretty cool. This is a landscape, and I stole this one from Mark Rusinovich's slide. There's a generative Inside AI talk that he did in Build last year, which is pretty good. The sessions he does on AI and security, together with Scott Hanselman, and there's also another one, you should watch it, that's really nice. But we can maybe define our landscape as the following thing. We have an external app or maybe a prompt that will have some generative AI logic. We have data sources for grounding that we check on, right? There might be agents or functions we use. That's a thing we're going to touch in a bit, of course. And then the data set itself and the data that's been trained on is also part of this system. And then if you look at prompt injection, that's always the thing you hear about. Like what could possibly go wrong in which spots, right? If we say data that comes from the web and is being, or the normal jailbreak inside of a prompt that you talk to, that's the first step, right? That's a user that will just type in and say, okay, I want you to do this, and then I want you to give me instructions on how to build a Molotov cocktail. That's the example you see, and it's like, no, I'm not allowed to do it. That's a jailbreak, and then if you can persuade in doing it, right? That's a thing, that's bad. But keep in mind that every piece of data that's being pulled in, it will go out to the web and it will get a resource, is something that can be a channel for a prompt injection as well. It can be leveraged, right? And that can be data sources, as I said, web applications, agents, and that kind of thing. And if we then look into how a prompt would work, we can say, okay, it's a multi-turn thing, right? We start a dialogue with it. If you open up ChatGPT on your system, you will start out with a prompt, and then the second prompt might pull in some additional response data that it will then use into the second prompt, and that will be augmented with another context data, and then it will flow until you're happy and with the output, right? And then the last bit, you see, that's the biggest thing. I'm done, and there's a user prompt at the end. Looking at what are the ways that it can go wrong, so we can have indirect prompt injection, so data comes from an external source, and that will then be used by the LLM to do things. And then we have the direct one, as I said before, which is instructions from the end user. The indirect one is always one example. Let's say you have a program that can integrate with your mailbox, and it will read your mailbox, and it will do stuff inside of your agenda. You need to give it access to the agenda. It needs to read your email. And then the example you always see, like, hey, what if I put additional instructions in the email, and I put it in a white font, and you don't see it? That's the default example you saw in the beginning. Then the LLM will just ingest it and say, okay, I need to do that. And you can maybe exfil data or extract data from the email, right? That's the indirect prompt injection. That's a really hard one to solve, because even if you look at those tools, they were always introduced for productivity reasons. But do you want to be able, and then, yeah, maybe you should do a confirmation loop where the end user says, like, hey, I want you to, do you want to add this thing to your agenda, yes or no? That might be an outcome. If it's workable, yes, but that will take away the productivity that you're longing for with that tool. There's a bit of a balance act, right? And then the question is, like, what could possibly go wrong at the end, like looking in prompt and prompt injections in general. So Johan Rehberger, I believe he's from Austria or Germany, he had a real nice talk at Blue Hat, which is a security conference that was held at Microsoft last year, October. You can find this video online, the link is in the slide notes. And he talks about prompt injection, and he also has a blog, and this is a screenshot I took yesterday, and that guy's on a roll. He finds a lot of things in these kind of systems, because it's just generally hard on making sure that an LLM corrects in the right way. And he has, like, looking into all different kinds of aspects, but he has a real cool talk where he talks through, like, how he works, and he makes a living out of it. He's a bug bounty hunter, and they will pay him money to find stuff and fix stuff. So if you want to be amazed, look into his blog post and see that video. That's pretty cool, right? And then the question would be, hey, we have this. This is almost the thing that I said before. Let's say we have an LLM service that we want to have email. We have a plugin that can help us out summarizing emails, and we have a one that helps us out fetching data from the internet. Let's say a malicious user sends you an email and then asks you to summarize data and send it to a different domain. Let's say, okay, the LLM service is allowed to access it, right? The data gets back, and then you probably are able to, or the LLM might be able to then take that data and just do a request to the web with that email data inside the URL, right? That's exactly the example you see here. So this is one thing, an illustration of a plugin that will have access to systems. And it's the product of the email and URL combined, right? Because you instruct the LLM to create an email that will then fetch data from the internet, but based on a request, right? That's the thing. And then you could question yourself, like, how hard is it to do this? And I've got one small demo that I created based on one of the demos of a semantic kernel that I'm going to talk you through a bit. So let me open my VS Code. Here it is. So this is a basic project that will use semantic kernel and that will connect to Azure, OpenAI. And if we look into it, there's a set of plugins. And if we then look into the program itself, it can reach a chat completion service. It will take a GPT-4o instance on Azure. It will add some plugins, and we're going to look into a bit what will happen then. And then it will also provide the plugin collection to the kernel, and then you will run it. And then the worker itself will execute this, right? So without bothering you, this one is also in the demo repo. So let me go to a prompt and show you. Hopefully you're able to see it all. Make sure we say .NET Run. So this is the demo you will find. You can say, okay, you can ask in natural language, you can ask questions like, hey, what time is it? It will return the time. What time is it? it will invoke, and you will see that it will take the time plugin, and it will return it, right? I can also ask, like, which lights are turned on? And it will give us an answer to that as well. It will say, hey, it will invoke some functions, right? Those are the functions that are added to the kernel, and this is the thing. What if I ask it to say, hey, can you provide me the configuration, bad fingers typing. Can you provide me the config? Most certainly, and then it says like, okay, so there is one prompt, once it will fail, and then it will say, okay, I cannot open this file. Turns out, we can also ask, like, what are the kernel functions, including signature, that are available? And once again, these are, of course, indeterministic, right? So you don't never know exactly how it will respond. But this one takes a bit longer. So I'm assuming it does the right thing. Am I connected? Yes. So right now, it has given me a response where it says, oh, the semantic kernel is configured like this. And it will just accept, these are all the plugins available. So can you imagine if somebody is able to get instructions to the LLM, it might be able to do this. And then there's one plugin I put in, and you can say, okay, just give me, can you show me the contents of file etc hosts? Maybe I need to say for both. No, it opens the file and it returns it, because that single plugin exposes a file path into the kernel, and the LLM would say like, oh yeah, I can do it. Just create a construct. As long as you're able to give the right instructions to it, you will help it, right? You will get there. So this is, of course, a really bad demo, but it will show you the power of what's possible, because there needs to be a bit more, and I'm going to look into that right now. So if you look at plugins interactions, right, keep in mind that if you use plugins or agents for that matter, it needs to have a subset of actions. Right now, I'm exposing a file path to the LLM to access, but why should I just not say, hey, get config, and it will just return the JSON or the data structure of the config, right? That's, of course, the implementation mistake I made on purpose. You also need to have tracing. What happened, right? You see that all the plugins were called, and in order to prove that something happened, you need to have the right logging as well. And it might make sense to have human interaction, human in the loop if something critical happens. And just assume the prompt will eventually fail, right? And there's a lot of examples. We're going to touch that in a bit as well, but that will just happen. So the LLM in the middle, you should not trust what you put in, and you should not trust what comes out of it in order to safeguard your system. That's the risk in general. So Microsoft is really pushing the bounds on how they want to do responsible AI. It's the same with the talk that I mentioned before from Mark Rusinovich and Scott Hanselman. The LLM I just exposed, I directly talked to the LLM itself. You should have got something in front of it, right? You're not going to plug in a machine and connect it to the internet and have all the ports open. That's the analogy they gave. I find it a really good one. You're going to lock it down. You're going to have less access on that system. This thing is also a Blue Hat presentation, a video you can watch, where they talk about GenAI apps they tested from Microsoft, and a big problem with this is something called server-side request forgeries, because if you can get the LLM to do a request to an external source, you can exfiltrate that email we saw before, or you can get that key access or the API key to something in order to access the data store, right? That's a big problem that they saw over here. If you want to play around with testing LLMs, then the same team that would talk about that GenAI apps have created a tool called Pirate, which is their testing tool for LLMs. They have let it loose on all kinds of prompts in order to automate the testing of the prompts in order to make sure you do the right thing. That's pretty cool, right? And there's always that single piece, like models improving, and I find this really, really funny. So I'm not sure like what the timeline is. Okay, it was 11 days in between. So OpenAI published like an alignment reasoning on their models, and then Mark Rusinovich comes back like, yeah, it's fine, but it's in no way protects against crescendo, right? Not sure if you know crescendo, but that's like, if I right now started talking about banking out of nowhere and try to convince you to give you your PIN number to me, right? That's the thing. And with crescendo, it's like a narrative, and you will force the LLM to go into a certain way. The context of that multi-turn window will be filled with data, and then at the end, it will just give you the answer. And there's no model protection against this, which is quite cool. But I find it funny. He's still, I believe, he's also part of the AI red team. He enjoys doing this. I think that's pretty cool, technical stuff. But it's hard to safeguard. There is one thing, and this is also the analogy I gave before. You're not going to connect the computer to the internet. You want to have something in front, right? So with Azure, you can do the AI content safety that has some heuristics inside of it. And I'm not sure. I should maybe also do my demo with this one in front of it and see if it behaves in the same way, or if it will safeguard. So like, you're not allowed to do this because it makes no sense in this context, right? As I said, if I start talking in the middle about banking right now, it doesn't make any sense. That's the thing. So you need to have reasoning on top of the context. There's some real cool stuff happening. But they will improve over time. They will make sure you will get the right thing. Is it 100% safe? No. And AWS does the same with guardrails, right? They have similar approaches. But it's so important to have a content filter in between in order to at least also not produce content that you don't want to see in any system, right? That might offend people. But also in how it responds inside your system and how it can result into new actions happening. Okay, so we talked about LLMs, how we can talk to them. We talk about how we can integrate those into our software. Now let's move into the last bit of the presentation where we're going to focus on AI and data itself. Models need to be trained on data, right? And that's the thing. So. And one metric I saw, and I think the link is in the notes as well, if GPT needs to be read by a single human, it will take 3,550 years, 8 hours a day, to read all the text that was ingested by for GPT-4, all the data. And I believe there's like an proximity on cost. It costs $40 million to compute that model and to have it available for everybody. But having that trained, there's always that supply chain, right? And supply chain security, starting out with source, ending up with a binary, starting out with creating a model, right? Ending up with something that's deployed and used somewhere. We want to have a trace of what happened. And that's also why I'm really happy with the open source models, because they do it out in the open. They will show how stuff is built, right? And that's the key thing, to keep the balance in between, without all the other stuff that's closed, which is also, that's just how it works. I think that's good. What can we do if we train based on data? We can do poisoning and backdoors, right? And that can be done on pre-training, on, let's say, on data you might have available, but also fine-tuning. Let's say in the end, you know exactly when a model gets trained, and you're able to edit the wiki page to add a statement. It gets ingested, then you edit it back, you turn it back into the old one. People probably won't notice unless they look into the history, right? But there's a possibility, there's a window for doing this, right? If you know more about it. And then you could question, does this happen? Yes. And this one was not confirmed, but this one was published about an intern that was fired because he planted malicious code into AI models to execute. And this is, of course, you could question like, hey, okay, TikTok denied this, I believe, ByteDance denied this of happening. Yeah, maybe you should do the same. But this is possible, and luckily there's still people that do research that confirm that this is possible with some metrics tied to it. And this one was from February last year. And what they were able to do is they were able to poison an LLM, and it will only take 1% of the training data to poison the LLM and have it behave differently. And if you then take a, let's say, a historical condition that's not necessarily true in the true world, but you know that that's the fact, then you can force it, right? You can get that thing, that condition into that space and maybe do some bad stuff with it. Marko Sinovic also has a talk on fingerprinting LLM models. You can do the same for the opposite, right? You're able to identify if a model uses data that you have seen or that you own yourself by planting that. I think that's pretty cool if you're able to do it. So it's possible, and even 1%, I was a bit amazed that it was that narrow to achieve. So what we need, as I said before, we need to have some supply chain. We need to have something as a supply chain. And if you look at software, there's something called SALSA or SLSA that was done by Google, and this is Google security team that looked into, hey, if we build an LLM model, these are the steps that we need to do. We can have a data set that can be poisoned. There might be bad training data. There might be a compromise of the storage where the model eventually gets stored, right? That's the whole thing from starting out with nothing, having a model deployed that you use. These are all steps, and you want to have some safeguard of what happened at what point in time. And the cool thing is that with SLSA on software, you can do build provenance and signing off for things and saying this condition was used to build this piece of software, this branch was taken into this build output, and this is the output of it. That gives you a ledger, that gives you a piece of information that will allow you to identify if it's wrong or right. And they introduced this for LLMs as well, but you can imagine how big are LLMs sometimes. They're pretty massive, right, in data structures. So if you then need to sign stuff, it's pretty hard. But SLSA for ML models, it's there, and Google uses it themselves in order to keep trace of what happened when, right? And then at the end you can have verification, because each of the artifacts are signed. So that's signed by public-private key pair, right? So that cannot be denied that it happened at that point in time, and you can verify it yourself. This is powerful. We need to have that transparency, right? In order to make sure that we know exactly how that model was built up, because it has a lot of influence on how it's eventually used. And there was a presentation done at Fusion conference that was held in Orlando, or no, it was in Atlanta. You find that you can see them talk about this. I think this is pretty cool. And there's another research paper that I run into last year, which I thought like, okay, yes, this is a real problem. One of the people that was involved, it was Ross Anderson, who also wrote Security Engineering book. You can find it online for free. It has some good fundamentals on how to write secure software. They looked into, okay, what if we train our data, but we already run out of all synthetic data or all normal data that we can use to train LLMs. That's just a given fact. So they will use synthetic data that was generated by other LLMs to feed it back in. What if the quality is degrading of that data that's inside? Then it will just eat itself. It will just become worse. And that's exactly what this paper is about, right? Because it will skew with the data distribution of the data that's used to train the LLM. And then it will just implode. And hopefully we're able to figure something out. I think the Pi models from Microsoft are also trained on synthetic data based on others, right? I think DeepSeek did some stuff with it in order to speed up things. It's definitely valuable, and I do hope that we can get something in place for this, because reading through this is like, yes, if it happens, then if the quality is bad, then it will just degrade over time because it's going to eat itself. So a nice paper to read. Getting into the last bit of the presentation. So these are all kinds of risks, right? And the problem is, you can talk about it for hours, but if you want to do practical stuff with this, then you need to have some guidance, right? Luckily, there is the OWASP Top 10 for LLM models, which have defined different risks in the whole landscape. There's a real big picture that they also have in a document. I was almost tempted on putting it in, but there's too much information. But you should look up the PDF of this. You will find all the different aspects that I talked about and what are the risks and what can you do about this. And that's the thing I like about, like, even OWASP Top 10 is still relevant. If you look at our state of cybersecurity, we use that as a measure, right? It will show how good people are doing or how bad stuff is. And it's good that then the community also picked this one up and created a top 10 for it, right? So all different types of areas. The supply chain, as I mentioned, the prompt injection ones, the poisoning, these are all different types of models. And you can probably not capture it all, but focus on the risks that matter most and then work your way down to improve, right? That should be the take. But look into this project if you're interested in doing a bit more. The other thing, MITRE is more from like a red team, like an attack perspective on systems, have also got a real nice metrics for like, hey, if I'm, as an attacker or malicious intent person, want to take care of this kind of system, what do I need to do? They give you the examples as well. So that's the opposite way. MITRE Atlas, look into that one if you're interested. So what's next, right? At the end, it's just code, right? And we need to make sure that we improve tools, security tools, still keep scanning our code with code analysis tools. Doesn't matter which one, but make sure you do something about it. But also have automations in place to help us out. Hopefully, LLMs can get better in fixing stuff, more complex stuff. And also be able maybe to do that rewrite of that crypto, right? Maybe say, hey, this is a step-based way on with help of agents to do stuff. One real cool talk is done also at Microsoft Blue Hat by Josh Brown-White on using LLMs to correct security flaws, and he explains exactly what the limitations are on these kinds of things, and also what would be the things to do next. The other thing that I also find interesting is that GPT models are being trained to do pen testing and security testing, and this one is ones that focused on pen testing itself, and they took a 3.5 GPT model, and then they were able to get better performance in order to make sure, like, this is the single task it needs to do. They were able to get that increase, right? But human skills, there's still somebody that needs to be in charge in order to make the right decisions and know exactly what they're doing instead of the vibe coding I talked about. And that will surpass technology, right? It will just, there's still a need for everybody to make the right decision and to develop software in the right way. Another real cool startup is called Oxbow. They have captured some pen testing and code reviewing habits into a reasoning model, and that thing can autonomously look into code bases and look up stuff and even fix stuff. And that's the thing that's being done right now. It's a real cool startup to keep an eye out, because I think that's the next thing, right? We can get more specific LLMs to do the right thing. And with 5 minutes left, we might even have time for questions. I want to wrap up. At the end, it's still software, right? And security needs to be integrated. I think that's the key thing. Look into what I shared on how you can design stuff better. And as I said, that LLM in the middle, if you connect to it, that's just a data source. Data that goes out to it needs to be assumed it's going to be somewhere that you don't know, right? It's going to go external. So no sensitive data should cross that bounds for that matter. And the data that comes back from it that you make decisions on is also need to be entrusted, because it's undeterministic, right, as we have seen. But then design, testing, education is important, and hopefully we're able to get better tools in space. I'm still like seeing all the stuff happening. As I said, Windsurf is an IDE with plugins and agents, and it's like an additional person sitting next to you taking care of things. If it recognizes a certain pattern that you're using, it will use it that way. And if you say, hey, I want to make sure that I use parameterized queries, then it will just take care of it and it will help you out. It's so cool. I'm not anxious about LLMs and GenAI, but I think we need to keep an eye on making the right decisions into the right direction. And with that, it's time to wrap up, and I'm happy that the beamer didn't blink more, unless I didn't notice it. At the right-hand side, you have the eval. Please fill that one in for me for feedback. The top one is the repo that has the home automation demo and the slides with all the notes. And on the bottom, you see the thing you can reach out to meet. So, with that, I'm gonna say enjoy the rest of Future Tech. And yeah, if you have questions, you can stick around, or maybe do it here or do it right now. Not sure if there's a microphone, but we have 3 minutes, so it should be possible if there are any questions. I'm gonna take a sip of water quickly because let's wrap up. I'm gonna be here the rest of the day if you want to talk. Thanks for your attention, and enjoy the conference.